side here, guys. Separate this. Now let's move that 12 over. I was asking you about this, she was trying it, she says that 12's been moved over professor. I will tell you ahead of time, this does not factor. If anything at all, you can either complete the square or use quadratic formula. Now if I apply quadratic formula, let's see what's going to happen here. We're not factoring. X is equal to -1 plus minus square root. I see a 1. Subtract 4 times 1 times 12, quadratic formula. All over 2. Step back and look at it. You guys agree? Trouble is, you get -1 plus minus. Underneath that, I think it's 1 subtract 48. Is that 1 subtract 48? Is that negative 47? All over 2. Now what in my directions there says, don't even consider that. It says find the real solutions. If I said find the solutions, then specify they want it. They want everything. If they say, use the word complex, they definitely want everything. So guys, our real solutions are, to finish that up, where is it? +3 and -4. If though, just in case, anyone tell me what this would look like if it were open, and you could include, let's say complex was used, rather than real. What does that look like now? I heard I. Radical 47. All over 2. And there will be 2 more answers. If that should happen. It did not happen, I just asked this for the real solutions on this. Guys, I don't want to take too much time there on that part 1. That part 1's easy. Just use common sense there on the absolute value. You have 2 cases, and you go from there. Okay? Now, if that's said, you could easily do that same thing. Part 1 is there. Now, part 2, we're done. We're done part 2. I did the inequalities already. Now, whew. Wait, hold on, just 1 second. Whoa. I'm gonna throw this at you guys. I'd like to solve that. That's not on the handout. Let's solve it. I have to solve that equation. No need to pick pencils. Can't solve it. That's going to tell me why can you not solve this? No solution. I mean, no I, in fact, nothing. It's impossible. How on earth can absolute value be equal to a negative? No solution. No solution. I thought something else. What should I do before I close all this down? Just in case. Oh, I should probably get myself in trouble. That. Solve for X. And back into the inequalities. And I will tell you, if you're clever, you need not go back to the 2 definitions I gave you to find which fits. You could. No, a little common sense on this one. A little bit easier. Yes.
All real numbers.
Okay, all real numbers, because he says, I don't care what you replace X by, professor, do your business here. Take the absolute value. This left-hand side is guaranteed to be a positive. Or it could be 0. I see, I sorta, let me see if I got it here, yeah. I see one number you can't use. Oh, you can use 0. There's nothing wrong with 0. 2 times 0 is 0. 0 plus 3 gives me inside there 3. Absolute value of 3 is 3, and 3 is greater than 0. There's one number you can't use, which is written. Minus 3 halves. You replace X by a -3 halves. The Twos will cancel, give you a -3. -3 plus 3 gives you a what? 0. Absolute value of 0 should be exactly what? 0. I did not place the equal mark here. So the way it looks right now, everything would work except 0. Looks like this. An interval notation. Now if I did, as he gave me an answer, if I had done this, now what's the answer? All reals down, everything works. Okay. Little notion about absolute value. Got 10 minutes here. Go for it, go for it.
Why 0? Why minus
I thought you could replace x by a negative number because you want to take the absolute value afterwards. Whoa! Hang on. We'll choose right quick again, number down here. Negative infinity up to 0, we'll just choose, guys, lots of numbers down there, infinite number of numbers. I'm going to choose -10. -10's in here. If I replace x by -10, will that satisfy the inequality? 2 times -10 is -20. -20 plus 3 is -17. Absolute value of -17 is 17. Is 17 greater than or equal to 0?
But you said we can't use one number.
That was up here, somewhere.
That's before, yeah.
That's before I did this.
Yeah.
You can't use, what was it, 3 halves?
Yeah, minus 2.
I mean, -3 halves? Yeah, when I put that equals mark on there, that opens it up, you can use anything
I
now.
was talking about not without the.
What's it now?
I was talking about not.
Oh, okay, but you see what I did there?
Doesn't that say you can't use 0?
Which one?
The interval notation right there.
Oh my goodness. Okay, hang on. Oh, you're saying right here. I got you. You're saying, Professor, are you talking about this?
She's saying the value for x that you were saying in the left-hand side that you cannot use is -3 over 2, correct?
Oh, I got you. That's what you're saying.
So an interval notation. Yeah, that's what she was saying.
That's what she's saying. You're saying back here, when we're trying to randomly select number, you give me a -3 halves. You're saying, Professor, you cannot let x be a -3 halves. Right? So you're saying, Professor, are you telling me it should be written like this? I think this is what you're telling me. Arena, is it? Is that it?
Yeah.
That's what maybe you guys are looking at, right? Is that true?
Yeah.
And then when I did this, that's the one I think I had in mind. Now, does that open up that everything we included? Is it true? Okay. Guys, that help?
And I have one more.
Go ahead.
2x plus 3 is more than 0, then x more than minus 2. So it's not for minus 2.
If we're saying you cannot use a -3 halves, that's the only number you cannot use here. Then interval notation looks like this.
So we're not solving the problem.
No, we're not applying one of those rules back on the inequality, we're just trying to use a little common sense on this. Whew. Okay, no problem. You got anything else on this? Now, I see I've got to use all the time I can get here today, guys. Next part says, section 3.1, we're in chapter 3, polynomial functions. Hope I have enough of these. Okay, guys, are these handouts helping? Some students are shaking their head yes, and there's some professor, I don't know what's helping. Yeah, they're helping, okay. I don't think I gave you any specific examples. I said what, section 3.1, and then what, polynomial function, and what it looks like, and then this handout goes along with that to give you more description of what a polynomial function might be and how to graph it. Let's go real fast for us. I know it's almost time for a break here. See. Okay. Now, all I want to do before we take a break, I'm going to have a student read for me that form that a polynomial function takes, but here goes. Get this out of the way. And we're gonna take a break. When you were back in middle school, they may do this in elementary school now. Part one. If I use this word, some of my students will come to me and say, wait, Professor, I've sort of heard something like this way back. I may not have been paying much attention at that time, Professor, but I do sort of remember sitting in class and that teacher talking and saying something like this. More than likely, at this point, before pre-calc, some of you have had pre-calc, you probably think, wait now, I know nomial. Seems like I've heard this. Monomial? Then I heard this back in the past. Binomial. And more than likely, they went up to, for middle school, probably this. Trinomial. Now, can anyone describe for me monomial first, we'll get the binomial, and I think even back then, these prefixes gave it away. Anyone describe what on earth am I talking about? Because they're all grouped into this word. They're all known as polynomials. Anyone remember what a monomial was back then? Or maybe I should jump down to the more obvious one, binomial. Or try. And you just give me an example. Does anyone have an example of what they think maybe this is, or this is, or this is? Because all these are classified as this. An example of a monomial? That you think might be one, for an example? I'm going to do it right quick, we'll run out of time here. X, 3x, 4x squared y, a single term. Monomial. Binomial, I need two. A plus b, x squared plus 3x, and others. Two separate terms. Trinomial, prefix, I need three. Maybe something like this. Make it look more like what we've been dealing with. X squared plus x subtract 6. Well, that's three terms. Now you're on Math 2 now. No, you're not in elementary or middle school. Those days are gone. I hope you enjoyed it. We can have 4 terms, 5 terms, 10 terms, 25 terms, 100 terms, it goes on. And sometimes they'll have names for the next few. I've got monomial, binomial, trinomial, those are terms you probably recognize. Just out of curiosity, does anyone know what 4 terms? What name is given to 4 terms? A 4-termed polynomial. Does anyone have an idea? There's a name for it. We usually don't hold you responsible for it, because I think monomial, binomial, trinomial might be enough. But there's a name for 4 terms, there's a name for 5, there's a name for 6. So they have specific names for the others. I'm more concerned just about the basic ones here. Okay? Guys, that's what it's going to look like before we take a break. Gia, tell the class what I have written, and then we'll take a break. On that handout for a standard form for all polynomial functions, called P of X.
P of x is equal to a subscript n.
Yes.
X superscript n plus a subscript n minus 1 x superscript n minus 1.
Okay.
And plus a subscript n minus 2 x superscript n minus 1 plus.
Minus 2 should be.
Oh, sorry, plus, yeah, minus 2 plus, and then it's the dot dot dot.
Right.
Plus a 1 plus a.
And then plus a subscript 0 on the end. Guys, in mathematics, I don't care what grad school you go to, we do it here also. They say all these polynomial functions can fit this form. And for the break, this that she gave me is known as my leading coefficient. My leading coefficient. This, the highest exponent, is known as the degree. Got a leading coefficient stuck out front, got a degree. By the way, notice that degree she gave me, the n, it then drops down to n minus 1. N minus 2, I would expect the next one to be n minus 3, n minus 4, and so forth and so on. That's in descending order. Means you start with the highest and drop down, like you did back in middle school. Something else I should point out, this last term on the end has no x with it. It's known as a constant. No x. And that's what we're going to be working with after we get you. Guys, oh, it's perfect. 15 minutes.